Worksheet 12E. The stress block shown represent the stresses on the two orthogonal planes through a point in a structural member. Using the Mohr circle, determine the normal and shear stresses on plane AA through the point. This problem is actually worksheet 12C, but now we use the Mohr circle instead of the equation with the analytical method that we did in 12C. So with that, as you can see, if you're not sure how to determine the angle theta with the plane AA, you can go back to worksheet 12C to find out that theta. It have two methods that I show you there. So I just want to just show you and remind you here, the theta by definition is the angle from the original x-plane. The x-plane is the vertical plane in the right, the plane divided by the axis perpendicular to it. So the x-plane to the plane AA, so that is the angle theta. In this case, as you can see, from the original vertical plane x-plane to plane AA is clockwise rotation. So with that, as you can see, that angle theta, it will be inverse tangent of opposite 4, the slope triangle 4 over 3, and that 43.1 degree, and that clockwise. And clockwise being, if you use equation, it will be negative 53.1 degree. So again, go back to worksheet 12C, you have all of that. And 2 theta, because this problem to do the Mohr circle, everything have to time 2, and you see that in worksheet 12D. So 2 theta is equal to 106.2 degree and clockwise. And the stress blocks of this one, sigma x equal to negative 1400 psi, sigma y equal to 1000 psi, and tau xy for the analytical is negative 500 psi. And if it use the Mohr circle, the one you read in the Mohr circle, it have to be for x-plane is positive 500 psi, because that tau on the positive x-plane, the vertical plane on the right, basically the tau create a clockwise rotation on the yellow block. So with that, we already know how to draw the Mohr circle, find out the center, sigma average, and 0 for the y, and then find out the radius equal to tau max. So that circle we already talked in worksheet 12D. So I just want to show you, okay, now with that all of information, and we be able to draw the Mohr circle. And we also in worksheet 12D, we also determine where is the which point represent the x-plane. So the one represent x-plane is the x with coordinate negative 1400 plus 500, because divided by in the Mohr circle. And the y-plane, which is the top plane horizontal perpendicular to the y-axis, and that is here is the y 1000 on the bottom right, 1000 psi, negative 500 psi. So that is the x-plane and y-plane. And now where is the AA plane? And as you can see, we need everything in Mohr circle. We have to time 2 theta, 106 degree clockwise from the positive x-plane, So with that, we use the compass here, the compass. Use the compass to measure this. Measure this one. So we have the compass. We use the compass to measure the angle 2 theta. So put the compass there and rotate the compass so that it will find out the x-plane, so that you can see now. Put it in the center and go to the X plane and find out the angle that theta equal to 106 0.2 degree clockwise. That is 2 theta. So clockwise. So as you can see from that, we can draw the line from 106. So it's about that point clockwise from X. And the plane that we going to draw is that plane here. Go through the center, as you can see there, that plane. So let's make that my shape here a little bit bigger, and that is the AA plane AA that we are talking about. A plane AA, because that it rotate an angle 2 theta from the positive X plane 106.2 degrees. So with that, you can put that angle here from this positive X plane to here with the angle 2 theta. And that angle as you can see here 106.2 degree. And whatever you read in the vertical line from that intersection with the point to going down here, that is the sigma x apostrophe, and that sigma x apostrophe happen to be equal to 6.15 psi. And what you have, the line, draw the line parallel to the horizontal, we see the normal straight, and whatever you read it in there, and that is the negative tau xx x apostrophe y apostrophe. So that here 1000 psi. So that make that one a little bit bigger here, go down to this side, and that one it go to that okay. So that you have negative tau x apostrophe y apostrophe, because as you can see in the Mohr circle, the sign convention of the tau and the sign convention of the tau in analytical are not the same. So let me remove the protractor so that we easy to find out. So with that, as you can see, at negative tau xy equal to 1000 psi. So the answer will be, if you use analytical, the answer is sigma x apostrophe 6.15 psi, and tau x apostrophe y apostrophe is negative 1000 psi. So with that, as you can see in here, we have 1000 psi. So from that, in this plot, we can see the sigma xx, it will be sigma for the plane A, it will be positive, and that equal to 1615 psi. So we can have here 615 psi, and you can see that. And then the tau x apostrophe y apostrophe, and that equal to 1000 psi. And why we put negative in the Mohr circle, and you can see in the Mohr circle it's a positive number 1000. And what does that mean in the Mohr circle? It's positive, is will be tend to create the block in clockwise rotation. So it means that it will be make a clockwise rotation, so that it will be go down that way to make the block in the clockwise rotation. And as it go to that clockwise rotation, as you can see, then it will negative, because it's opposite to the positive y apostrophe axis. So that's why you see that is it negative in analytical, and the answer if it analytical is 1000 negative 1000 psi. With that, we move here, and then we put for the tau xy in there for this tau, and the tau here, as you can see, it equal to negative on that plane because it's opposite to the positive uh, y-axis. So with that, we done for this problem.